Hubble published his discovery of the expansion of the universe in 1929. He had observed an almost systematic redshift of the light emitted in galaxies by Cepheids. He interpreted this shift as a galaxy escape causing a Doppler Fizeau effect. This phenomenon confirmed the hypothesis of the expansion of the universe, put forward by Abbé Lemaitre in 1927 as part of the theory of general relativity. The acceleration of the universe's expansion was discovered in 1988. This acceleration requires the presence of dark energy in space. Its gravitational force would be repulsive. But it emerged in 2024 that this dark energy varies over time. The expansion rate of the universe could have been faster in the past. For the theory of general relativity, gravitation would be an action of space-time, a mathematical continuum, on physical bodies. Einstein stated in 1924 that, we will need the ether, that is, a continuum endowed with physical properties, which theoretical physics cannot do without, for the theory of general relativity, excludes an immediate effect at a distance. Any theory of near impact requires the existence of an ether. This Einstein ether has therefore been expanding since the beginning of time. This expansion drives galaxies, which move away from each other at speeds that are higher the further apart they are. These speeds seem to exceed the speed of light at the far reaches of the universe. In reality, the distortion of time and space, in the theory of special relativity, keeps them below this absolute limiting speed. From the beginning, the redshift of Cepheids in galaxies was interpreted as a Doppler Fizeau effect, resulting from their escape velocity. The Hubble constant gives this escape velocity, as a function of the distance from the galaxies. However, it became apparent in 1998, that this constant increases as a function of the distance from the galaxies. The Hubble constant is not the same for Cepheids, and for cosmic microwave radiation. The difference, the Hubble tension, is 73 to 67.6, or 5.4 km per second per megaparsec. It was therefore assumed that an undetectable dark energy filled the universe. This energy would act as anti-gravity. Things didn't stop there. In 2024, astronomers discovered that the density of this dark energy is not constant. Dark energy gradually dilutes. The evolution of the universe has become evident. It now appears to be more complex than the mathematical vision of the space-time continuum, of the theory of general relativity suggested. A mathematical vision of natural phenomena emerged after Newton and Maxwell. Since Einstein, scientists have been searching for equations that would account for all the forces of nature, the famous unification. And in the progressive movement, these equations must be based on absolutely invariable universal constants. How could the evolution of the universe be based not only on an accumulation of absolute invariants, but also on completely immutable properties of matter, such as the mass of particles in atoms, over billions of years? It's totally paradoxical. Fluid mechanics completely escapes these scholarly speculations. In fluids, not only is there not the slightest trace of a perpetual constant, but nothing is invariant, in changes of Galilean reference frame. However, fluid mechanics puts forward an explanation for the redshift based, precisely, on the conviction that everything in the universe evolves. If the mass of atoms increases over time, then the wavelength of the light they emit gradually decreases. The increase in the gravitation of the nuclei of atoms with the mass, causes an increase in the acceleration of electrons during jumps, and therefore a decrease in the wavelength. The light emitted by atoms in galaxies, therefore reaches us billions of years later, with a wavelength longer than that of the same atoms today on Earth. We therefore observe a redshift proportional to their distance. It is pointless to assume that galaxies are moving away from each other at astronomical speeds. The increase in the mass of atoms, especially of their nuclei, can only come from condensation. Therefore, matter in space is needed to fuel this condensation. One can think of the invisible dark matter imagined to explain the curve of galaxies. The stars in galaxies rotate at speeds independent of the distance from the eye of their galaxy. This dark matter would act on the stars, in such a way that everything proceeds according to Kepler's laws. It could fuel condensation, but it would have to be uniformly distributed throughout the galaxies. This is not the case. One can also think of Einstein's ether or any other form of ether whose components must, however, have mass, which is not the case for the ethers, imagined within the framework of Maxwell's electromagnetic theory. This is necessarily a gravific ether. This gravific ether necessarily has a limited extent in space. An action is required to limit its extent, just as gravity keeps the atmosphere relatively confined around Earth. One might think of an electric field or a magnetic field. In the current state of knowledge, fluid mechanics does not provide an answer to the limitation of the gravific ether extent. However, the pressure of the ether must decrease as it approaches its outer limits. Consequently, condensation must be slower and atoms grow more slowly in this region located billions of light-years away. The redshift of galaxies located in this region must, therefore, be greater than that which would result from distance alone. This explains the Hubble tension. So there is no need for dark energy. The outer reaches of the gravific ether are characterized by a light emission, called the cosmic microwave background. But since our galaxy has no reason to be at the center of the universe, an asymmetry is observed in the measurements of the cosmic microwave background, as shown by the representation of the measured redshifts. Our galaxy is closer to one side of the ether's periphery than to the opposite side. Galaxies located at the same distance from Earth, but in opposite directions, will therefore not have the same redshift. The redshifts are therefore not symmetrical, which could explain what has been interpreted as the variable rate of the Hubble constant. Dark matter has no relevance to the problem of the supposed expansion of the universe. The speed of stars in galaxies is independent of their distance from the eye of their galaxy. It does not obey Kepler's laws. Astronomers therefore imagined that gravific matter, called dark because it is undetectable, would be distributed throughout space, in such a way as to make the velocities of stars conform to Kepler's laws. Within the framework of gravific ether condensing in matter, fluid mechanics provides a solution to the problem of the velocities of stars in galaxies. The gravific ether is assumed to be composed of particles with a momentum, but also with angular momentum that is transmitted transversely. Hamilton's principle implies that any condensation of this gravific ether toward a well begins to rotate, and Poincaré's theorem causes the resulting vortex to concentrate in a plane, perpendicular to its axis of rotation. The condensation velocity is obviously 1 on r square, according to Newton's law, and in this fluid with angular momentum, the tangential velocity is 1 on square root of r, consistent with Kepler's laws. In this well vortex flow in a fluid with angular momentum, the variation in the angular momentum of the fluid's rotation as a whole is not equal to the variation in the angular momentum of the fluid's particles. Compensation is required, which occurs through pumping of the particle's angular momentum. The flow law can only conform to Kepler's laws, as long as this pumping is negligible, at great distances from the eye of the galaxy. Moreover, the wave speed in the gravific ether is the root mean square of the agitation speeds of the particles that compose it. The transverse transmission of angular momentum explains the transverse properties of the waves that can propagate in this gravific ether. If ultrasound in air is highly directional, even more so waves in the gravific ether retain the transverse dimension of their emitter over very long distances. These waves have all the properties of light and gravitational waves, differing only in wavelength. So Descartes was right. Gravity and light belong to the same medium.